Hello everyone, welcome to the channel. Today I'm going to cover Helm Charts. So I'll discuss what Helm Charts are, how to install those, then little bit about Helm repos, and then we will create our first Helm chart and deploy it to Kubernetes cluster. So why do we even need Helm Charts? To understand this, let's assume we have an application. That application have multiple resources config map, deployment role, service account. And we need one more application similar to this. So that also has same resources, but of course the names and the labels would be different for it. So when we create a second application, we'll have to update the name, label, and some of the minor details. And if we want to create few more applications like this, then it will be a overhead for us. Let's say now we want to add a new resource to all of our applications. Like we want to add secret to few of the applications. Then we'll have to create those configurations and then apply those configurations to every application that we need to update. So this results in a manageability issue. And to solve this, we use Helm charts. So what we can do with Helm charts, we can create a configuration once and then just apply variables to that configuration and deploy multiple applications with the same. It will make the manageability very easy, and we can share those packages with others to use them or to improve them. So, what is Helm? It is a package manager for Kubernetes applications. It is used to manage complex applications. It is easy to update. It's very simple to share with others, and it provides a rollback feature for any changes that we're doing. So, how to install Helm? I'm using Mac OS. So, if I do brew install Helm, it will simply install the latest version of Helm that is available. If you are using something else like Windows, then you can go to the installation guide from the Helm documentations, and you can see there are few package managers that Windows support, like Chocolatey, Scoop. You can use those commands to install Helm. If you're using Linux, then there are few other commands that you can use. Once Helm is installed, right now I have used 3.17 version. So you can now run the Helm commands. So let's start with few simple Helm commands. So there is one Helm search repo. So what this does, whatever repositories you have available, Helm search repo will simply list all the repos that are there. And there could be multiple different repos that you can maintain on your system. So you can add a repo as well. So in the documentation, it mentions that we can add a Bitnami repo. And once you add it, you'll see like these are all the repos that are available in the Bitnami. So there is Airflow, Apache, Argo CD, and lot more. We can use any one of these repos. There is a EKS repo that I had added before. So in this also there are lot of applications which can be directly deployed on the Kubernetes related to EKS, right? So I have AWS Calico available, and there are load balancer controllers, termination handlers, and stuff like that. So let me pull one of the repo and let's check like what happens. So once I pull this repo, it will download a zip file for it, and if I unzip this particular file, it will show all the files that are inside it. So if you see in this is a sort of structure that a Helm chart has. It has values. There is a chart.yaml, and then there is a templates folder. So this chart is version v1, and in the templates folder you'll see there is a helpers.tpl. There is some CRS, custom resources, and then there are some CRDs. So this is chart that is created by AWS for EKS. Like now, let's say we want to create a chart of our own to manage and maintain our own applications. So if you do Helm create and then name for our chart, so let's say first hyphen chart, So it will create a folder, first hyphen chart, wherever you have executed this command, and then it will have some files already available there. So chart.yaml has the API version and the chart version as well as the application version that we're setting. If you go to the documentation, you'll find that this is the structure that the create command generates, and chart.yaml file can have these all configurations. So not all of them are required. Only the ones that you're seeing here, the first three, those are the required ones. Others are optional. So you can ignore those for now. Just for understanding purposes, I want to spend more time in explaining what the templates and how these files relate to that. So that will give you practical understanding of how to make your own charts and how to use those. So in the values, you'll see there are a few things mentioned, but let's go to templates. And in the templates, you'll see there is deployment.yaml, hp.yaml, ingress.yaml. If you look at the hp.yaml, there is, if you look at the ingress.yaml, you'll see that there is if and then values.ingress dot enabled at the top. So that means, let's say this value has ingress enabled, only then it is rendered, otherwise it is not considered. So this pattern that you're looking at, right? So this syntax is Go templates, and I'll explain this syntax you bit by bit. I'm not going to cover everything, but at least I'll enable you to understand what this means. So you see here there is an indent 4, and then there is an indent 6. What this means, it's simply the number of spaces before this statement. Like there are 6 spaces, so it is 6. If it is 8, then there are 8 spaces before it, and if it is 12, then there are 12 spaces before it. So it's a very simple and straightforward statement. It has nothing to do with the logic. It is just a YAML file that needs correct spacing, and to ensure the syntax is proper, that's why we need to mention this particular function. You'll see here in the image, values.image.repository, then there is colon, and then values.image.tag. After that, there is a pipe, and it defaults to .chart.app version. So values.yaml, that is the file from where the dot capital V values that is coming from, right? So here it is replica count image. Inside image, there is a repository. So values.image.repository, values.image.tab, values.image full secrets, and things like that, right? So in the service account, you'll see service account create is set to true. If I go to service account, you'll see at the top there is if condition, if value service account create. So that is true, and it is true. And that is why whatever is mentioned below that, that will be added as part of our chart. Otherwise, it would have been ignored. So let's understand the deployment.yaml file. It says include first chart full name. What does this mean? If you go to helpers.tpl, and if you search this particular line, then you'll find that there is a define statement. So what include actually calls a function that is defined in the helpers.tpl. And what this function says, like it is defining this function, and below it says if values dot full name override, then do this, that is values dot full name override, duplicate it to 63, and trim any suffix with a dash. So if you go to values, and if you look here, you'll see that full name override, that is set to empty. And if this is not empty, then it will use the full name override as the first hyphen chart dot full name, right? And if that is not the case, then it will go to the else statement. And this dollar name, this is actually defining a particular variable. And what this means is this will use default as dot chart dot name if the dot vary. So if dot values dot name override is not specified. So if this name override is specified, then it won't take chart.name. But if this is empty, then it will take chart.name. Below it says like if contains $name with dot release dot name. So if release dot name contains the name, so this is a chart name that you're seeing. Release name will be defined when you actually install this Helm chart into any cluster. So you will have to give a name or you can generate a name, but when you give a name, it is called a release name. And if the $name contains release name, then it will execute this statement. Otherwise, it won't do anything. So it will just print that, yeah, this is the release name and tourniquet it to so and so number of string, a number of characters, and trim the stuff. So that is the meaning of first dot chart full name. Now let's come to the labels. What does label mean? So when you look at the definition of first hyphen chart dot labels, it says like helm dot sh chart. So this is one of the labels that it's going to add, and it will take this particular item from another function. So it is including other stuff like label select, there is a selector labels, and then there is a chart function. So it will render these two, and then it will see like what is happening. So selector label is just below, and it is just adding two statements like app.kubernetes io name and instance. And if we have chart.app version defined, it'll add the version. If we don't have it, then it won't add it. Similarly, you can see like there are a lot of other include statements that are being called. If you look at the statement, this is with statement. So what happens? Any pod annotations, like pod annotations, might have multiple values, and all those values, let's say if they are not in YAML, then they will be converted to YAML. That is what to YAML is for. The dot just like renders everything that there is, and indent it, that means like whatever spacing there is, it will honor that spacing. It will add 8 spaces to that particular statement. So that particular line item will have 8 spaces before it once it's converted to YAML. So that means the entire document that we are specifying, that will be correctly indented. Even if let's say when we pass these values, there might be some sort of mistake. If there might be space, there might not be space, but this particular line item will take care of it. So if you scroll to the values.yaml file, so here where we have all the variables, so pod annotations, it is empty as of now, and you'll see it is an object, so it is not exactly in the format of a YAML file. But if even if we set those values here, the template that we have, that will convert it to YAML, and then it will appropriately indent it. If you look below, then there are in the label section, you'll see that, yeah, first chart labels are also being added, but with that, we are also adding the pod labels. So pod labels will come from the values file. And if you look at the specs, we are including all the imageable secrets that we have. If you remember the imageable secrets, that was an array, and if it has multiple values, that will be added here in the YAML format as well. So if you look at this service account name, this again is a function because it is saying an include statement. And if you look at this, the definition says if value dot service account dot create is true, then it will set default as include first dot full name. So it will execute this function, and it will say like, yeah, the first dot full name, whatever it is, set it as default if the values dot service account dot name, that is set to null or empty. So if that is empty, then the first chart full name will be applied. Otherwise, the service account name, whatever we have set there, that will be applied. So if I look in the values file, as of now, the service account name is set to nil, so it will fall back to the default chart name, default chart full name. Otherwise, it would have selected whatever service account name we have given. If you look at the image parameter, it says a repository, then a tag, and if there is no tag, then by default it goes to app version from the chart. So you look at the file below and it says like with statements and things like that. So this will give you a basic understanding of what a Helm chart looks like and how to build a Helm chart on your own. The default parameters that the default file structure and the files that we have got, those are pretty much good enough to understand what Go templating is. If you want to understand a bit more in depth, then you can use this document. The document is not very clear, but yeah, it is a good reference. This document can be found in the Helm chart template section, and there it goes, and there it links to the Go templates. It says like whatever things that we're using, all those are mentioned here, like different parameters. There are a lot more parameters than this as well, and those can be used. There is one file called .helm ignore. So this is a similar file to .get ignore, and whatever files folders that you patterns that you mention here, those will be ignored from the chart. So that covers what a chart looks like, but how to use this chart, right? So let me create another folder after hyphen help, and inside this, I'll create my hyphen val.yaml. So this is my values file. So the first values.yaml file, this name cannot be changed. It has to be values.yaml because that is someone who is defining those values initially, right? But when somebody who's applying that Helm chart, they can name their file anything. It does not have to be values.yaml, but it has to follow the sort of pattern that the default values.yaml file has set. So in this file, I'll just mention that yeah, full name override should be my first app. Now I have made a mistake here. I'll just execute this once and show you what the mistake is. But for now, yeah, this file seems fine. I'll just add the name override as well. And okay, the both the set things are same. I'll just remove the first from name override. So just my app and the full name override is my first app. Now, if you look at the documentation, you'll see that how we can provide the variables that is with help of -f flag. And if you run the command helm install -f, and if you give the file path, so the file path was dot slash, so the from the current directory I need to go to the after hyphen helm folder, and inside that I have created a new file, my hyphen val.yaml. And now the chart that I'm going to use, so that will be dot slash first chart. And if I run this, it will say like generate name is not given because I have not specified any release name. So if I don't give my own release name, then I can generate a name. And if I generate a name, what will happen? It will create one of its own sort of a dummy name. So right now it is giving me an error. It says like invalid value, my first app. I have given a camel casing there, and it does not accept camel casing because actually the service account cannot be named like that, or a lot of things in Kubernetes cannot be named like that. So what I'll do, I'll give a hyphenated name, and that will resolve our issue. So please keep that in mind. You cannot use any sort of alphanumeric format that available. You have to ensure. So please keep that in mind. Now, if I apply it, it'll be applied, and you see the name is like my chart, and then something something. After that, some random numbers are there. If I get deploy, if I get kubectl deploy, then if I get kubectl, if I get Kubernetes deployments, I'll see like yeah, the application is deployed, but the first uh, Helm deployment failed. So right now there is one. So first Helm chart installation failed. So right now there is one that is in the failed state and another that is in successful deployed state. So you can uninstall any charts by Helm uninstall and whatever the name of that particular release is, and I'll remove both of them. And after that, let's do a fresh installation. Okay, now both of the charts are removed. So what I'll do now, I'll update the name to app-v1. Okay. And I don't want to give a random name that is being generated. What I'll do, this is the command to deploy it, right? So I'll remove the double hyphen generate hyphen name, and I want to call it, let's call it a web app, right? So after I'm giving minus F, so let me add web hyphen app. So what this will do, this will call my release as web hyphen app, and the first chart is the chart that is going to be used. So you can see the name is web hyphen app, and if I do Helm list, I'll see all the charts that are installed. It took some time. Okay, web app is installed, it is deployed, and the revision is one. Now that is very important. The revision is one. Let's say I want to make some change to my application, right? So after making that change, I want to redeploy it again. So if I run the install command, then it will say no, the name is already in use. You cannot use that install command again and again. So let's say I changed it from V1 to V2. So what I'll do, I'll upgrade it. So Helm upgrade, and then the variables, and then the same release name that I have used, and the same chart that I had used. Okay. So the variables were updated a little bit, and now it says like, yeah, the revision is number two, and the web application, the release has been upgraded successfully. Okay. So if I list it, it will show me that, yeah, there are two revisions, and the second revision is the current revision. Okay. And it'll show me the chart and the app version, but yeah, I have not updated it. I've just updated the deployment name. So if I do kubectl get deployment, I'll see that, yeah, now my deployment name says v2. Let's say I have added few more details, right? And I'm deploying another set of revision. So what I'll do, I can, let's add an image tag. I'm not adding it, but let's assume I have added that. And now I want to update the name as well. So I'll just call it V3. Okay. And if I, let's say, apply it, but I know that, let's assume the application code has some fault in it, but it's not some fault in it, but for some reason I still apply it. Okay. So I upgrade it. Now the revision is V3. But I want to roll back the changes, whatever changes I have made. I just want to roll back them because there is some sort of a issue with the code. The deployment is not working properly. The pods are not coming healthy. I'll see that, yeah, the revision is three right now. I know the last working revision was two. If I look at the deployment, it says V3. But let's say I want to roll back it to the last working revision that was V2, right? So what I'll do Helm rollback, then the name of the release that I want to roll back, that is web hyphen app, and the revision that I want to roll back to. So that is two. I just apply this command, and you can see after some time it will take effect, and my revision would be rolled back. So rollback was success. If I run kubectl get deploy, it will show me that, yeah, app v2 is currently running. And if I do helm list, so it shows revision is 4 because the second revision was applied as the new revision. So the revision is of course incremented. But if you look at the deploy, the application is in v2 deployment. So that is the one that I required. So rollback is successful. So these are the few cases that we can use with the help of Helm. And it is a very powerful tool. Let's say I have 20, 30 applications, and most of the applications have similar sort of a pattern or not that many changes with them. Then I can create as one or at most two charts, and those two charts can take care of a very complex deployments that would be difficult, let's say, with lack of expertise. So Helm really helps us to package things and to manage those things, and also to upgrade, roll back, and share those charts with the others. So that's all for this video. Thanks a lot for watching, and please subscribe to the channel if you haven't already.